Okay, so right now I'm working on page 371, number 7. And what I did was I plotted all of the information for Timmins in my first Y value, so the blue. So Timmins is all of the blue data, and Miami is all of the red data. So what we're looking at is temperatures over the course of a year. So it's one period of a year for each function. So now I want to analyze each of them. We'll look at Timmins first. Okay, so let's look at Timmins first. The period would be 1 year. The amplitude, if we look at the maximum, which would be on our here, is 16.1. Subtract the minimum, which is 8.3. So the distance is 7.8 between the maximum and the minimum. And then if you divide that by 2, so the amplitude is equal to 7.8 divided by 2, or 3.9 units is the amplitude. If the amplitude is 3.9, then the equation of the axis will be 3.9 units up from the minimum, or 3.9 units down from the maximum. So let's find the equation of the axis. By using 16.1, subtract 3.9. The answer is 12.2. So the equation of the axis is 12.2. Looking on here, if this is 10, my equation of the axis is just above the 12. Excellent. Now let's move on to Miami. So now we are looking at the hours of daylight throughout the course of the year in Miami. So on the 15th day, for instance, there's 10.7 hours of daylight. On the 165th day, there is 13.8 hours of daylight in Miami. So what I would like to do is now discuss the period, the amplitude, and the equation of the axis. The period is the time for one complete cycle, so we're going to say 1 year. The amplitude is the distance between the maximum, half of the distance between the maximum and the minimum. The maximum for Miami, looking at our data, looks to be 13.8. And the minimum for our data looks to be 10.5. So we're going to find the amplitude. 13.8 minus 10.5, that's the entire distance from the max to the min. And that's 3.3. That is the entire distance from the max to the min, so we need to take half of that. 3.3 divided by 2. The amplitude for Miami is 1.65. The equation of the axis would be halfway between the minimum and the maximum. So we'd want it halfway through the curve. So if I'm looking halfway, I need to either look at the 13.8 and subtract the amplitude, or look at the 10.5 and add the amplitude. So I got 12.15 for the equation of the axis.